All right. So I was kind of telling everybody what our plan was for tonight. So without further ado, why don't I let you loose? I'm going to go ahead and get my ugly mug out of the camera. Thanks for coming tonight, guys. I'll also be streaming some play if anybody's bored tonight after we do this. So there, I am gone. Now you can see everything in its glory. So Porgy, how do we start by telling us how do we apply power from our power supply, whatever, what voltage are we going to use for powering the Rigmaster, and where does that go on the device, if you could be so kind as to show us how that works.
Okay, so again, I want to stress that this is specifically for the Arnoz boards because I know with Mike's boards and some other solutions, they use different power voltages to the boards provided. So for the Rigmaster, this board itself, and as well as all of his boards, it is powered by 12 volt. So we are feeding 12 volt to the board. On the left side of the board here, if you look closely, you'll see that it's marked 12 volts as well as toys. So that's my ground. That's powering the board. And I actually have a distribution block down here that's distributing 12 volts to all the boards right now, so that it has, the ability to, to distribute power now to each of these boards. So when I turn it on here, you'll see that they have a nice blue glow, and we now have some power to the board. So just so you guys can just kind of going over, a deeper dive into the Rigmaster. We have 12 volts here. We have a ground here. I know he labels it toys, but this is actually the ground. Each one of these grounds can handle up to 20 amps. So this board can support up to 40 amps. So uh, or 20 amps per ground in his board. So if you have a lot of toys, if you're running 50 60 toys, you might want to make sure that you're checking out how many amps you're running. Because of this example, we're only using one ground for now, and that's provided back to the distribution block. That ground is very important. If you guys don't know anything about connecting a full circuit, that ground is basically feeding back to the toy in some way, shape, or form through the MOSFET, through the fuse, and giving us that full circuit when we connect the toy to the Rigmaster. So if you think about any toy, you're providing power to the toy. You're then grounding it into the Rigmaster, and then the Rigmaster is grounding it into your distribution block, which then again grounds it to your power supplies. And that's kind of the example we have going on right now.
Okay, and like you
Yeah.
said, on mine, we connected all three of the grounds, right? Because we had so much power going from all the different voltages and all the toys and Mullis that I'll be adding on later.
Yeah, so it doesn't hurt to hook them up. So in to me, especially if you're running 24 volts or even 48 volts, it's good to have those multiple grounds grounded in. As you know, and you found this out, David, you can't just plug in a ground into into the Rigmaster, and then the 24 volt, let's say it's a 24 volt toy, and running your 24 volt toy right to the 24 volt power supply, and running that ground somewhere else where it's not connecting the full circuit. It has to be a continuous complete circuit to power up the toy. So um, in this example, we're only running 12 volts here. We have a distribution block that's breaking it out, but if you look here on my screen here, I'll pull this up. I got an alligator clip here. This is actually connected to my uh, 24 volt power for my toy that I'm powering, because I don't have a 24 volt block here. I only have a single block for 48 volts.
Okay. Side note, Porgy, I sent you a note in Discord real quick.
Up properly. Okay, so um, just to give you a little bit of layout here, just so we could talk about the layout. I know we're not going to go over everything today. As you see, and we talked about these parts in the last video, the Rigmaster is your main driver. We have a KL shield that's mounted under the board. this red cable's running into. That's what's powering the PC, or giving the data back to the PC that is then feeding the Rigmaster to do what it needs to do. Um, we have obviously our output, the expansion for the output on the mollusk, which is running over here. We have our inputs, which we have on both these inputs here that we're not utilizing right now, which right here we can hook up the brain. We can hook up, our inputs here, and then we have our plunger here as well. Discord.
Just so you know, I'm having an issue that when you talk,
Still there with me?
I am, but we're having an issue where you're coming through my microphone channel somehow. So I'm just muting out while you talk. We should be good.
You still with us, Smog? I think we lost you. Okay, sorry. No worries. I just want to make sure I'm still coming through.
Okay, we should be good now. Go ahead.
Okay, and again, so we have our inputs we're not using today. We have our plunger. We have our power distribution, which we're connected to, and then we have our outputs. We have 8 digital outputs, 8 PWM outputs. Right? I know we talked about that a little bit, Marty.
Yep. So the digital are for toys that don't require any adjustment, and the PWM would basically give you control over the intensity of your toy. For instance, lights or a shaker motor, right? That type of thing.
Yeah. So the way I like to explain digital outputs is, ones and zeros, right? One is on, zero's off. It's full, it's all or nothing, right? That's how a digital output looks. Um, if you take a PWM output, you could do something where it's basically giving pulses of the signal, and that pulse can be a higher intensity or lower intensity, which allows those intensities to use a more amperage, I guess, to those toys. So let's give you example, like a shaker. You can set up a shaker where it's a PWM output, and it will reduce the intensity of the shaker, so it's not going crazy when it goes out off. Where in a digital output, it's going to go full force no matter what, right? Or
Yeah. So
same with the solenoids. We don't want a solenoid to stay on all the time. So through flipper logic, through those PWM outputs, we can say, okay, after 50 or 100 milliseconds, turn off that output.
that's not
It doesn't stay on, it doesn't burn up a coil.
and flipper logic isn't exclusive to PWM. That can also be used on the.
It is exclusive to PWM.
Okay, good to know.
Yeah. Yeah, you can't use that flipper logic in because there's intensities too, or it's just like a start and stop time. So that's part of the PWM. It's on and off.
And when you attach, so you get 8 of those on a Rigmaster, okay? And how do you go about choosing your fuse for the toy you might select?
Yeah, so there's 2 types of fuses, right? There's your fast blow fuses and your slow blow fuses. Your slow blow fuses are typically the ones you're going to be using for something that might have a higher current that can drive through them for like almost like an arc time, like a coil where it might go up to 3 amps, but it doesn't utilize 3 amps when it's actually triggering. It might just have these misfires or a point where they just hit this high amperage, and that way use a slow blow fuse so that it doesn't blow the fuse every time that happens. It can eat that that small spike for a second without blowing the fuse, but after if it continues, it will burn the fuse, so it protects the board. Where a fast blowing fuse, no matter what, if it sees that spike, it immediately blows. If it's within the amp, if it's outside the fuse limit, it's going to blow that fuse immediately and it needs to be replaced. When you're first working on these boards, I do recommend using fast blow fuses just so that you are learning what you're doing, you know what you're getting into. Make sure you're using the right amperage. I have you know, a machine here that I can actually test the amperage output on it based on when I hook up a toy, seeing how many amps it's using. It's a good thing to have is if you're doing this, or at least make sure you have some type of spec sheet on what you're putting into your system, because you're going to want to know, okay, is this coil use 2 or 3 amps? Like these specific coils I have here on the chimes, these use 2.1 amps. So if I put a 2 amp fuse on them, they're going to blow. So I need to use a 2.5 or 3 amp fuse, and they could spike up to 3.5 amps. So having a slow blow fuse, I can put a 3 amp fuse on it and I don't have to worry about it blowing. And then I'm also protecting the board. So
Okay.
there's just those two different types of fuses. They definitely help. The fast blow fuses definitely, in my opinion, are the ones I would start out with if you're new to this, just so you can make sure and make sure you put the right amps in there. It's going to help you down the line.
All right. So that kind of walks us through fuses, what they're about, some of the logic behind them. I'm sure we'll see some more of that logic when we go into the Pinscape software later.
Yeah.
The next thing I wanted to ask you about was obviously I need to connect two things to any given toy. So you got a solenoid I see in your picture there, just to name one. My understanding is that I have to apply power to that device. Does that come from the Rigmaster? How do I get power to that device? If you could go over that for us.
Yeah. So I guess that's somewhat of a loaded question, because going off of the Moss Lite, and we'll cover the Moss Lite in further video. The Moss Lite does actually have power provided off of the board. If you you can actually see that here on the far right board here. It's actually providing 12-volt power to the toy that's sitting here, because that's the way the board was actually designed. It has 1 amp. Each one of these support 1 amps, and it's a low enough low enough output that it can handle providing power as well as your 3 grounds, because it's RGB, to the board. Where something like the Rigmaster, you're using dedicated power.
Well, we're talking about the Rigmaster tonight, so
Yeah.
I'm a little confused. If I'm going to power a toy like that solenoid, does
Yeah.
that power come from the Rigmaster?
It does not. You're grounding that toy into the Rigmaster. You're actually getting power from your power block. So when it comes to power, you're gonna have some type of distribution. You're gonna have your grounds all together, because you want your grounds to be able to talk to each other. You have a common ground, and then you're gonna have your, let's say you have 12-volt toys or 24-volt toys. You're gonna have separate power supplies for those. Your toy specifically will have 12, that power source going into its positive lead, and then you're going to ground out your toy into the Rigmaster to complete the circuit.
So I'm going to come from my power supply with a wire into the positive end of the toy.
Yep. So I'll show that example here. I have the Siemens contactor here. I have your 24 volts. I'm connecting 24-volt power to the Siemens contactor, and then I'm grounding it, which is the negative, to the output on the Rigmaster. That's
Okay.
completing a full circuit, because I'm also getting, grounds from here. From this ground is tied to the distribution block, which also ties back to my 24-volt power supply. So that completes the circuit. But right now, if you think about it in the easiest sense, there's some type of switch in there. It's either a switch, or you can think of it as a relay that's off right now. And when something triggers the event, it'll turn it on, basically opening that circuit and completing the circuit. It's gonna then turn on the toy.
Okay. That makes sense.
And we can even do an example of that if you'd like. We can show that.
Well, you just kind of floated into the next section, which was, after you power it, how do you connect that to the Rigmaster? So for the case of the solenoid you've got, where are we going to connect that? A PWM or direct? What would you like to do in this
Yeah, so for
example
now,
here?
I have it in a PWM output here, just so I can turn on flipper logic, and I can make sure that this specific device doesn't stay engaged all the time, if just in
Okay.
case there's a hiccup in the system.
Okay. So
Yeah.
we've connected the toy to the Rigmaster output. All right.
Yeah, so let me just show you the circuit. So right now, on the positive lead, this red lead is your positive power. I do have a diode connected on this, just to protect the toy as well as protecting the board. It's running, and the negative is running into
I
the
think
Rigmaster.
I think your screen is inverted.
It might be. I don't know how that's even possible.
Yeah, it's upside down. I can flip it, but when we flip back to your other image, you're gonna go upside down again.
Okay. Yeah. I
So
don't know how it projected that way. That's interesting.
yeah, isn't it? Isn't that cool? Do you want to flip it there, or do you want me to flip it here?
Let me see if I can flip it here. Let's try this.
Yeah, good practice, guys.
How about now? Is that better?
It's still upside down, so why don't you let me flip it? Yeah. It's upside down and backwards. Yeah. Yeah. Let's there you go.
Oh,
There you go, buddy. Now I'm gonna have to flip you back on the other scene. So go ahead.
yeah, that's fine. We'll have to fix that. So here is the tool that we're using just to kind of test the outputs. Um, this is your Pinscape control config tool. I can go in here. I can set up each. Let me show you guys here. I can actually go in and select the Rigmaster. The new firmware that just came out on, I believe, the 22nd of December now has the Rigmaster showing up right from Mr. J's guide. So you don't have to do anything weird to get the beta version of this, but let me load this up here. So you'll see here the Rigmaster is now available. I can add the teens mullet sports, which we'll do down another line, but this is kind of where that setting is configured. Let's scroll down. We're gonna set up the orientation. We can set up basically all the different things that the Rigmaster can provide for us. Selecting the plunger, what type of plunger it is, our inputs, what kind of inputs we're using, and then we get down to the outputs here. And I do have to correct myself. There is some level of flipper logic on the digital outputs. I apologize. So if you see here, I have a couple outputs that I've already turned on flipper logic in the PWM outputs there, which is 9, 10, and 11, and even 12 here. We're going to turn on 12. So basically, when I engage that toy, it'll only stay on for 100 milliseconds, and it will immediately kick off. So if you're using like a real solenoid, a real flipper, you're not going to burn that flipper up because it's going to engage, completely disengage, but you'll still be holding down the flipper in the game, so you won't recognize it, but at least it'll turn it off. It won't keep burning up the coil, and it'll continue working for a long time. So that's where you come in here. You turn on this flipper logic. You can even put a description in here if you need to, just make sure you're identifying each one of your toys. But basically, what you're seeing here, these are just outputs. You're looking at the outputs here. Okay. And you can identify them here through the first 16 ports are from the KL25Z, which is your Rigmaster. The next 16 ports I have set up is actually for the first mollusk and then the second mollusk for additional toys as you expand through the system, right?
Can you show us how to set up? Let's hook up the solenoid, and show us how to find that port here, how to configure it, and then maybe you can show us a test of it.
Yep, sure. So let's go ahead and program this. All right, and we're gonna. All right, we just programmed the KL shield for that change I made, which now is making it flipper logic. And let's go ahead and share the window, entire screen, so you guys see all this. And now we can go in and actually go to an output test. So test your output ports.
Do you want to have both screens up for this?
No, that's fine. Yeah, maybe but it's gonna be upside down, which is fine.
And we can't see the solenoid because it's under our images now.
I'll move it. Yeah, I got it. There we go. All right.
Should be good.
All right, so now that we can see in this picture here, when I scroll over any one of these outputs, I can actually see with a little blue circle which one's out lighting up, so it could tell me, okay. Um, and I have it hooked up to port 12 on the PWM. And if you look on the board here, that yellow cable is plugged into 12. So just by doing a test output on here, it clicks on and off. I don't know if you heard it actually clicked off there too. It doesn't stay on because that flipper logic's turned on.
I think I actually saw it move a little bit.
Yeah, I don't know if I can even bring it closer here. Maybe.
But we'll take your word for it. It's firing every time you turn it on and off.
Yep. So yeah. So right now we're just testing in the tool. Once we identify, now we know. Okay, so port 12 on the Rigmaster is set up for that solenoid for that contactor. So we can go into the DUF config tool on the VP Universe website, configure port 12 for, a sling or a bumper or whatever that coil is being used for, save it, and now it's going to be identified. The board knows to trigger it off of that port 12 because that's where we plugged it into, and it's always going to be completed in that circuit because, that's how we programmed it, and it'll know every time it triggers that it's only going to stay on for 100 milliseconds. Right?
So is it fair to say Pinscape is how I configure the toy to operate, and DOF config and DOF are the tools to load that config in and utilize it within the VPX and other software?
You got it. Yeah. Yeah, so this is really, like I said, the Pinscape setup tool here is really configuring your KL25Z. It uses the same interface for Mike's boards, for Arnos's boards, for just a plain Jane KL25Z, and gives you more options based on whatever you're using. So because now that we have the settings and ability to, click on Arnos's Rigmaster board here, we can go in and add any features that we need to, that are part of the board, to expand out to more toys as we get further along in the build, or however many toys we're adding here.
Okay. Do you have any other toys you want to show us examples of tonight?
I mean, I could just show you. I do have some chimes, and I'm not gonna lie to you. I don't want to fire them until they have some diodes on them. It's extremely important to have a diode on your toys. If you don't, you can actually burn up a MOSFET. You can burn up a diode. You can burn up even your board. So just to keep those protected, I'm not going to fire them tonight. But just to have a small example, I do have a flipper uh, PCB board here hooked up through the MOS light, though, coming through the Mullis, and I can show you that, just
Can you just take out the quick connect and put it into the Rigmaster by chance?
I did. Yep, I ran. You're talking about here?
Yeah, for a light test off the Rigmaster, just to show that.
I can. Hold on one second. Let me do that.
Because I do believe we can also put it on PWM and slide the slider and show the intensity difference, if I'm not mistaken.
Yep. So let me show. I'm gonna put this down to 12 volts. So I'm gonna actually unplug because we're providing 12 volts directly to this board. So I'm gonna take that out. So 3 inputs. We're gonna go ahead and put into.
And I think it'd be worth noting to people that some RGB lights are 5 volt, some are 12 volt. Please make sure you pay attention to your lights. Arnoz and his equipment usually runs off of 12 volt, but most lights in buttons that come default are 5 volt, and you'll probably blow it up if you apply 12 volts.
Correct. Arnos usually mostly 12 volts for all this stuff. All right, so I did hook up just by moving those 3 inputs over to the Rigmaster on ports 13, 14, and 15. It looks like we need to go ahead and add some fuses to those ports because they don't have any. So since they're lights, I don't need big fuses. I'm just going to put half of amp or quarter amp fuse into the board here. So 1 second.
Show us, oh wise one. How do you insert a fuse?
Yeah, and these are nice. These are nice. You just push them forward and they pop up. So we'll add some fuses here.
Oh, it's a little fuse holder like in your car.
Yeah, a little fuse holder. Yeah, you know what? Arnos made that very convenient. On all of his boards, he has fuse holders in them. So it's not an extra, board you have to add to the build. It's already there, or you don't have to buy anything extra. It's already part of the board. All right, so we added fuses to 13, 14, and 15, which is what we're plugged into for RGB. Okay, so just so you guys understand that on anything that's using RGB, that's not addressable LEDs that's going through the teensy, it will need 3 outputs per toy. So if you're using a flasher, if you're using these RGB like fire button or flipper buttons, those are gonna use a lot of ports. So a 5 bar flasher bar, for example, and Marty, you found this out pretty quick. That's gonna use 15 outputs, right? So
I don't know anything about connecting. That's why I'm here, man. You're teaching me.
well, that's what I'm saying. You're planning on installing a flasher bar in your build, right? So this is something that's going to be very handy for you.
Cool. Let's do that the next episode.
So I'm going to go ahead and go into. I'm just going to do test output on those. And remember, we said we plug those into 13, 14, and 15. So 13, that's powering on 13, red. 14 is green, then blue, and then if I turn them all on, obviously we'll get white. So.
Let me show you doing that in Pinscape. I didn't have the screen up. Hold on just a second. Can you do that again for us?
Yep. And if you look in Pinscape here, again, I'm back again into the output tester. I'm looking at the Rigmaster power. I'm going to power the inputs 13, 14, and 15. So if I click on 13, that will power on red. I want to turn that one off. Set the next one down to 14, green, and then final one is blue.
And can you slide the slider and show how you can move the intensity of that blue up and down?
Yep. You can see that will give you a lower intensity if you want it to be lower intensity. That's the nice thing about the PWM outputs. You know, you can even do those with your RGB lights. If you don't want them super bright, you can actually turn down the intensity on them. Where in the digital ones, it's all or nothing, right? So as you see, let's go ahead and put on white here. See you turning on all of them.
I would argue if you're going to be adding bling, you should go bling.
Absolutely. If you're adding it, turn it all the way up, right?
Oh, that's my personal recommendation.
Yeah. See, but all we did is hook up, 12-volt power to the PCB, and then we have our 3 grounds going into the Rigmaster, your red, green, and blue, and that's giving you your outputs. And if you look at Arnoz's board on the right here, it actually shows you indicator lights that are in blue. And as you see, when I'm turning them on, they're actually lighting up. So it's actually a really nice feature on his board. So when you're, you may have your virtual pinball cab open and you want to test firing of some of your solenoids, you can identify them very easily on the Rigmaster.
Okay. Well, that covers everything I had on my list for tonight. Is there anything else you think we should have in this video before we get to any questions or camaraderie with everybody watching us live?
No, I think just word of advice is when you start digging into this stuff and you're getting into some of these toys, just be very patient. Don't rush it. Make sure double check all your wiring, because it's very easy to blow a MOSFET. It's easy to get overwhelmed and pick the wrong fuse, and just to get things, you want to get things up and running. So take your time with these things. Make sure you're planning out your build, especially when you're using these bigger boards, because it has a lot on it and it can do a lot for you. You just have to plan it out. So that's really my big advice for it. I think we can. I was planning on showing you guys some of the inputs. That's pretty self-explanatory. I don't think we need to dig into that. I mean, it's almost like any encoder. You have to ground into the board, and then you need to provide power. Your input, which is the key pressing of any of your buttons. So we have a lot of those on this board. We have our 16 outputs, which we're using right now. If you look, we're actually using 4 outputs just by lighting up a single flipper button and 1 coil. So just plan your builds accordingly as you're going into.
Let's talk about it since you brought it up. I don't need you to show us, but you brought up inputs. Now, for a Joe Schmo like me who hasn't really done a lot yet, input, you mean buttons? Do you mean like my start button, my flipper button? You're talking about the control buttons?
Yep, yep.
Okay.
So your left right flipper, your Magma Save buttons, your start buttons, even your input insert coin is considered a micro switch, which is also considered a button. All these are programmed to some type of keyboard command. Um, so
So
that
what
keyboard command is what's giving you the direction of what it's going to do.
what I've learned since our last episode is we have this Rigmaster, which is essentially the starting point, an all-in-one, if you will, for all of your buttons that you might start with. And then if you decide you want to add a coin door type device like the brain you showed us last time, I see it there at the top, then we would... I'm sorry, I have to turn that around. So we have all the outputs for direct and PWM control. We have the brain for the coin door or other type of device, all the buttons. And then if we need more toys than the 8 PWMs and 8 directs we have, that's where the expansion comes in, which is there on the bottom right of the Rigmaster for a mollusk. And then from there, if you need more than one mollusk, you can daisy chain those together and continue to add as many devices as you want up to, do you know the limitation on it? Is it 128 devices? You might be muted. Well, sounds like we lost Porgy. That's okay. Well, that rounds up today's episode. I'm going to go ahead and end the tutorial session. We're not going to end the stream yet, so just for my own edification, there's Porgy. He's back.
Yep. Sorry about that.
I think we got it. I think we're good.
Yeah.
I'm gonna put my ugly mug back on the screen here.
Well, and just to answer to the people on the channel, yes, you can expand up to about 192 devices without any issue, more than you'll ever use.
Right.